All right, how to draw a force diagram. Number 1, draw a dot. That is going to be your object. Number 2, all forces are represented by an arrow and labeled. And all arrows or vectors point away from the dot. Now we're going to take a look at some examples. All right, a bird sitting on a stump. Start part 1. Ready? You draw the dot. That right there is the bird. Very exciting. Yes, there we go. I can see your dot, Michelle. Yes, that is a beautiful bird. All right, once you have your bird, let's draw the arrows on it. What forces are acting on said bird? Okay, good. Which way is gravitational force acting on the bird? F, G. Okay, this is where it's going to get interesting because I can't write very well on here. On bird by the earth. Okay, then we have our normal force on the bird by stump. All right, so we have the normal force on the bird by the stump. So if it's a fat bird, the stump pushes up farther, harder than if it's a skinny little teeny weeny bird. And we have gravitational force on the bird by the earth. Now, one important thing to note is that our bird is not accelerating. We have constant velocity. That means that this arrow needs to be the same as that arrow to show that our bird is not accelerating. Are there any forces pushing to the right or to the left on said bird? Nope. Cool, next. Ice skater moving with constant velocity on frictionless ice. All right, draw your dot. There is my wonderfully amazing ice skater right there. I'm such a good drawer. All right, what forces should I draw? The what force? You're saying that there's a sideways force. What's pushing her sideways? What's pushing on her? So, in other words, we know conceptually at some point she must have pushed off of something to get herself going. I do not care. The only thing I care about is what she is feeling right at this moment. What forces are acting on her right now? Yeah, sure, she must have had to push herself to get herself going. But when she gets going, she will keep going with a constant velocity forever unless there's another force to slow her down and stop her. So this needs to be the same as that, and that's it. How does it change for our roller skater? Moving to the right, and there's friction. Okay, so I see some backwards arrows. What is the arrow that points to the left? Good, frictional force. Okay, so what's keeping her going then? Because right now she's going to slow down. Yes. So, and more specifically, we're going to have the floor pushing on her, on skater by the floor. Because if she pushes on the floor is going to push back on her. If you've ever had like the banana effect, like you slip on a banana kind of a thing, or you slip on ice, you're trying to walk, you're trying to push on it, and it does not push back, and your feet go